Hey everyone, in the last video we defined our triangle class and we wrote out what we're going to put in our header file, and we started the three constructors in this CPP file. We added two new attributes. We still remained with three constructors. We have two new getters, and we are going to override four methods from the class that we are inheriting from, that class being shape2D. And we are also going to overload three operators. So after the creation of these three constructors, well, what comes next? The getters. So we'll define those first, and I will say that these belong to the triangle class, so I'll have get area, and this will be as simple as our other getters, and we'll just return the private attribute. And we'll have the same thing for our get perimeter. Again, I use the class and the two colons to tell the compiler that this method is part of the triangle class. Very important. If I didn't have that, it would think that is an independent method that doesn't belong to the triangle class. And we all know that this is not true. So keeping this in mind, these two, we are about to define our setters. So let's go about creating the skeleton code for this first. So we'll have void triangle set length, right? And then here I'm going to have void triangle set width. Oh, and I forgot the argument for length. So we'll have width. We will have double length. And the implementation of this set width is going to be a little bit bizarre than what we think. I don't just want to copy the code that I have here in shape2D with all these error checks, because this code's already written, so why don't I use this? So what I'm going to do is I'm going to say shape2D and call the set length function within. And then what I'm going to do is that I'm going to update area and perimeter within here. So area equals area and perimeter equals perimeter. Right, so I call this as this would normally do just by calling these by itself. But now when I call it for the triangle class, it calls it within, but then I have this additional update that's going on where I update the area and the perimeter. Right, so this allows us to augment our setters that we already have. So I'm going to continue the same methodology for width. So now when I call the set length and set width, it automatically updates the area and the perimeter for me. And I do that by calling the parent version first, which will do all the error checking for us. Then I'll update my new attributes here that I've introduced. And I'll do the same thing with set width here. So why don't we change all this, and I'll actually not be using this, and I'll be saying this. I will say set length set width. Same thing here. I won't have to call these because I have my own getter function that'll call them for me. And actually, why don't we put that here, and we'll proceed this with our try. And it's going to be get. I'm going to put these things here. So get width. There we go. So now this will be updated. Now let's see what happens when we compile these setters. No errors, and that's good. So now that these setters have been updated, why don't we go about implementing now the area? And this will start quite simply. Well, at least for the area. Things will get a little bit more complex when we go about implementing the perimeter because of how we are visualizing and implementing the triangle. So we will have this, and we will return 0.5 times our base, which is going to be our width, times our height, which is going to be our length. Right? We're not renaming these, we're reusing them. So this is going to be equivalent to saying area is equal to 0.5 times base times height, where our width is our base and our length is the height. Now, let's move on to probably the trickiest method in this entire class. So this is going to be the calculation of our perimeter. So the way that this triangle has been implemented is visualized by this series of comments. So I'm going to start off with the base, which kind of looks like this as some sort of visualization. Right, so we have, or it kind of looks like a tree, but bear with me. We'll have this, and we'll have this, and then here we'll have this. Okay, so this is kind of what our triangle is going to look like. And these straight lines here, and that should be going up here, this is the length right here. And then the width is the underscores here that go all the way down to the base. So because of that, when I want to get the perimeter, I need to find a way to calculate this diagonal line. So as a result, what I need to find is the hypotenuse of this triangle. So if I go about creating this triangle again, where we have this, right, I need to find this hypotenuse. So what I'll do is that I'll create a temporary variable, double, and I'm just going to call it HYP for hypotenuse. And how I'll do it is that I will say that this is equal to, I'll use Pythagoras' rule. So I will say 0.5 because I'm looking for this, and I need half of the width. Width is defined as this entire base, but I need to get half of the width. So half times get width, and it's going to be multiplied by itself twice. So what I'll do is I'll actually use the math library and take this to the power of 2. Actually, yes, take this to the power of 2. And then I'll do the same thing for get length. So I have power, or pow, and I will say get length 2. Right, so here, if this is my A and my B, I have my A squared times my B squared. It should actually be plus, not times. Oops, and this needs to be a method. This is a variable. There we go. Fixed all typos here now. Right, so now I get my A squared plus my B squared, and now I need to go about taking the square root of this. So in the next line, I'm going to say HYP is equal to square root of HYP. And that'll be it. It'll take my square root. And I found my hypotenuse. So what I'll need to return is the perimeter, which will be the base, which is get width, and 2 times the hypotenuse. So I'll return that here. Get width plus 2 times the hypotenuse. Right, and this is a way of calculating the perimeter. Right, and that's because I'm choosing my length as this middle line and my width as this bottom line. If I wanted to implement this triangle by saying that this is the width, which is the base, and this diagonal line is the length, well, things would be a little bit different here. But because this is how I'm visualizing how I'm creating the triangle, this is how I will do it. So what's left now is to override the equals operator and the plus operator. And here they are. So we have the same declaration as we do in our header file. And with this now, because I'm loading these values into the class itself, I use the set length and the get length for the try input and set it into my own internal parameters. And because get width and set length automatically update area and perimeter for me, I don't need to do anything extra, and I can return myself as a class. And the same goes for the plus operator. Since result is its own triangle, these set length and set width automatically update area and perimeter for me because I define that in the method above, the methods above here, so I don't have to worry about updating area and perimeter like I do with rectangle. And that is because I was able to override the set length and set width methods. And the operator uses the same methodology in terms of printing as rectangle. Almost exactly the same. Just here this is separated by a comma and a space, and here we are just separating by a space. So what does that look like in terms of testing? So in main, if I include my triangle, I can create some triangles. And here we'll keep this simple. And let's see what the result is. Okay, so now we have 9, 3. We get their area and their perimeter. Then we have, and this is T. Then we have T2, 11, 12. And then we have the area and the perimeter. And then we have their sum, which is 20 and 15. And then we have their area and their perimeter. So this looks good to me. And this marks the completion of the triangle class. In the next video, we'll start covering a concept called multiple inheritance, where a class not just only inherits from one class, but from two. We will begin creating something called an abstract class called Shape 3D, where we can start creating three-dimensional classes that represent three-dimensional shapes. Thank you.